Okay, part of this is going to be a review. First part of this is kind of a review. So if y equaled e to the e power, what would y prime equal? 0. Very good. Why? Yeah, e to the e is, thank you for your honesty, I don't know. E to the e is a constant because e is about 2.7. And so if you take 2.7 and raise it to the 2.7 power, you've got some nasty decimal, but it is a constant. So the derivative would be 0. All right, we learned this yesterday. If y is e to the x, what's the derivative of e to the x? E to the x. Good. You don't really need to put the dx because y prime is the same thing as dy dx. So the dx is kind of on the left side. It's like when we do a u substitution and we start with y equals e to the x, instead of doing dy dx equals e to the x, we do dy equals e to the x dx. Well, the derivative of x is 1. It's more that the derivative of y is dy dx, and the derivative of e to the x is e to the x times 1. And if you wanted to multiply both sides by dx to move it over to the other side, you could. All right, what would the derivative of x to the e be? Very good. E to the x to the e minus 1. That's just your power rule that we learned a really, really long time ago. So like if it was x to the 5th power, it would be 5 times x to the 4th, right? E is just a constant. So the derivative of x to the e comes down in front, and you have x to the, and then you subtract 1 from your exponent. All right, now, the one that we haven't learned how to do is taking x or any other number to a variable of x power other than e. E is special in that the derivative of e to the x is e to the x. But 2 to the x, or 5 to the x, or 1/2 to the x is special, and you have to do something else, or x to the x. And I put a frowny face by it because it's not necessarily hard. It's just a little bit of a pain, and there are a couple of extra steps. But what that frowny face means is that you're going to take the natural log of both sides. And the reason that I'm going to do that is the natural log of x to the x power. How can I rewrite that? Good. X times ln x. And that I know how to take the derivative of. I'll have to use the product rule, but I do know how to take the derivative of it. So the natural log of y, the derivative of that is what? 1 over y dy dx. Okay, and then x times ln x, the product rule would be 1 times ln x plus x times what? 1 over x. And you always want to solve for dy dx, so what do I need to multiply both sides by? Good. So dy dx. Yes. So inside the parentheses here, that's ln x, and the x times 1 over x is a 1. You don't have to simplify that, but I would prefer that you do. And then instead of writing y, the original problem was y equals x to the x, so I'd like for you to write x to the x in place of y. What, Emily? Okay. All right, so that's literally as hard as it gets, and yep, hold on. You okay? Is everybody okay? Okay. All right, so basically anytime you have something to the x power that's other than e to the x, you'll have to use this. It's a frowny face problem, and you have to take the natural log of both sides. So this one right here is a case where we'll have to take the natural log of both sides. So we have the natural log of y. How else can I write the natural log of 2 e to the x, or 2 to the negative x? Okay. Negative x times ln 2. Because taking the derivative of log base 2 is a lot more complicated than taking the derivative of natural log. Actually, no, that's not. Taking the derivative of a log other than base e, so other than natural log, is not part of the curriculum. All right, so what's the derivative of the left side? 1 over y dy dx. What's the derivative of the right side? Okay, the natural log of 2 is just some number. It's a constant. And if you have a constant times x, what's the derivative of that? The constant, yeah. So the derivative is just the natural log of 2, or negative natural log of 2. Okay, because we could write this as negative natural log of 2 times x. Negative natural log of 2 is just a constant. It's like 5. So the derivative of 5x is just 5. Yes? It doesn't matter. When you're using the product rule, it doesn't matter which one you take the derivative of first, because you add, in the product rule you add the 2, but the quotient rule you have to take the derivative of the top first. And you could use the quotient rule, I mean the product rule here, but when you take the derivative of ln 2, what would you get? 0. All right, so multiply both sides by y, and you get dy dx equals negative ln 2, and y is really 2 to the negative x. All right, so not so bad. Just you have to recognize that you have to take the natural log of both sides. All right, so the last one is similar in that you've got a number to the x power. So we're going to have to take the natural log of both sides. Now, how do I want to rewrite the right side? All right, the x times the 3 to the x, I'm multiplying the argument, so I can break it up into the natural log of the first one plus the natural log of the second one, and instead of 3 to the x, I'm bringing the x down in front. Okay. Yeah, you pretty much have to do that because the x is only attached to the 3. So if you wrote it as just the natural log of x times 3 to the x, you wouldn't be able to bring the x down in front. And that's what we need, is to get that x down in front. Gray? Well, there are no absolute values in these problems. There won't be. Okay, so the derivative of ln x is 1 over x. What's the derivative of x times ln 3? ln 3. And then the last step is just to what? Multiply by y, which is really whatever y is. X times 3 to the x. Okay, and that's all you have to do.